here we are. So, everybody, are you ready? Quick reminder here. By definition, I is the square root of -1, right? Okay. Yeah. Therefore, I to the first is equal to I. I squared is just going to be the square root of -1 squared, which would just be -1. And if I squared is -1 and I to the first is I, then I to the first times I squared would be I to the third, which would give us -I. And then if we have I to the first times I to the third, we get I to the fourth, or you could say I squared times I squared, however you want to think about it. That's -1 times -1, therefore I to the fourth is just +1. So here are our first 4 powers of I. And then if we keep going, it's just going to start over and continue forever. Now, keeping that in mind as we go through all these problems. So here we've got -5 plus 3i, the quantity squared. Please remember that this is what it means. And if you just say 25, plus 9i squared, then that's ridiculously wrong, okay? We need to use FOIL here. Will, please stop. Listen. So that's going to give us 25 minus 15i minus 15i plus 9i squared. And of course, I squared is -1. So we are going to substitute in just -1, which makes that whole piece -9. So 25 minus 9 is 16 minus the 30i after we combine those two like terms in the middle. So pay attention to that. So next is 2 minus 5i, 6 plus I. So no real shortcut here at all. We just need to go for it with FOIL. So that's going to be 12 plus 2i minus 30i minus 5i squared, and the minus 5i squared just becomes +5. So 17 minus 28i. So good with those? Okay. Now, we're going to use, or we're going to have, we're going to have complex numbers that we need to simplify at times. And since I, by definition, is the square root of -1, this particular fraction has an irrational denominator, so we need to rationalize it. So let's multiply by what? The conjugate, 3 minus I, exactly. So 3 minus I over 3 minus I. So we will FOIL the top, and we don't have to FOIL the bottom, we just have to FOIL, okay? So the top, 6 minus 2i minus 3i plus I squared. That plus I squared is going to become -1. To the bottom, since they're conjugates, just first and last, so 9 minus I squared. The minus I squared becomes +1. So now we've got 5 minus 5i over 10. Now, if you leave that, I'm going to take off a point, because we can still do what? We can still reduce it by factoring out the 5 and getting 1 minus I over 5 times 2. Cancel those 5s. So most simplified answer, 1 minus I over 2. That's most simplified. Good? Okay. Now, this next one is a beast. So I'm just going to get a whole new sheet of paper here. So here we've got 5i over 7 minus I minus 2 plus I over 1 plus I. I honestly think the best way to deal with this problem is to actually first rationalize the denominators, then get a common denominator to subtract. I did it the opposite way yesterday, and after I did it, I think that might actually be shorter to rationalize first. So let's do that. So if we rationalize first, this is what we're going to get. Multiply that by 7 plus I over 7 plus I. Multiply this one by 1 minus I over 1 minus I. And very honestly, guys, the trickiest part of the whole problem here is that minus sign, because that minus sign is going to need to be distributed to everything that follows it. So, but first, I'm rationalizing all the denominators. So, the new numerator here is going to be 35i plus 5i squared. We'll deal with that in just a minute. Then to the bottom, first and last, since they're conjugates, 49 minus I squared. Minus, keep going, 2 plus I times 1 minus I is going to be 2 minus 2I plus I minus I squared. And then to the bottom, they're conjugates, 1 minus I squared. Okay, so now let's take care of all the I squares. So this becomes negative 5. This becomes plus 1, plus 1, plus 1. So now I've got 35i minus 5 over 50 minus 2 plus 1 is 3 minus I over 2. Now, here's why I think that it's probably shorter doing it this way, because now this fraction is going to reduce, which is just going to make all the numbers smaller. What's the common factor over here? 5. So this is going to turn into, and I'll write it over here to save some room, take 5 out of everything, 7i minus 1 over 10 minus 3 minus I over 2. So now we can more easily see what a good common denominator is, least common denominator is here. It's 10. So let's multiply this by 5 and this by 5. Now, working it right down here. 7i minus 1. Everybody watching? Really, what am I distributing here? A negative 5. Everybody see that? Everybody see how it's going to save us some pain and agony if we distribute a negative 5 rather than have to then later distribute in minus? So this is going to leave us with minus 15 plus 5i all over common denominator of 10. And finally, combine the like terms and also take an opportunity here to put it back in, standard complex form, a plus bi. So negative 1 and a negative 15 is negative 16. 7i plus 5i plus 12i all over 10. Guess what? Still not done. What's the common factor, Mr. Carberry? 2. So take out a 2 out of everything. 8 plus 6i over 5. Most reduced answer there. Now, Will, calculator man. The old TIs actually used to simplify these for us. I don't know that the new operating system does it? Okay. So you just have to be so careful. It's the way that it looks. It appears sometime on the screen, so just be careful with that. Exactly. It gives it to you as decimals. And some people, foolish as they are, it also appears on the calculator sometimes as if it's putting I in the denominator. No, it's not. Okay? So be on the lookout for that. Now also know that when I give you one like this, I'm going to want you to show all the work by hand. Use your calculator to check your answer. Okay? Because it was very interesting. In college prep algebra, we've been doing problems like this, not with I's, but with X's and Y's where they have to add and subtract fractions. And they were like all shocked that I actually checked their work. I'm like, I always check your work to make you prove the answers, okay? So, because I had some people who magically had the right answers but no work to support it. That's a problem, okay? So, be on the lookout for that. I've got this up here if anybody wants that copy. Now, last problem on here. Really, anybody off the top of their head know the quick shortcut to do this problem? Yeah, we can multiply the constants together first. I would skip it. No, don't skip it. This one's actually quite easy. Here's the first thing I would do. I would use the commutative property and the associative property to change the order around. Everybody watching? This becomes 3 times 4 times negative 5 times I to the 20th times I to the 17th times I to the 81st. Think about it. Can't you do that? Yeah, you can do that. That's using the commutative property and the associative property to change the order and change the groupings. So now we've got negative 60. And then this, you could simplify each one of these separately, or you can just add all the exponents together. That would be 37 plus 81. What is that? 118? Is that right? 37, yeah, 118. Now, what did you say the shortcut was to deal with a big giant power of I? Divide it by 4, exactly. 118 divided by 4. That goes 2 times, 3 left over, 9 times, remainder 2. And what's the important part? What's the important part, the quotient or the remainder? The remainder, not both. Because here's what we're really doing. Everybody paying attention? What we're really doing is saying, okay, I to the 118 is the same as I to the 29th power raised, or other way around, I'm sorry. I to the 4th to the 29th power, or actually I could have written it the other way as well, times what? I squared. And what is I to the 4th? 1. And 1 to any power is still 1. So therefore 1 times negative 1 is just negative 1. So that's why all we really have to pay attention to is the remainder there. So now I can do another quick substitution. Negative 60 times I squared. Negative 60 times I squared is simply negative 60 times negative 1, which is positive 60. The whole thing reduces to positive 60. But the key here, just like Jonathan said, divide by 4. Just like Claire said, take the remainder and substitute in the remainder. That's the quick shortcut to get around it. But here's all the math behind it right there. Okay. Today, I'm going to make shorter videos and see if that helps.